Namaskar, I am KG Kapoor, safety professional and farmer scientist DIDO. Today we will discuss under the banner of safety philosophy and principles of accident prevention, safety by design. Earlier in two lectures we have discussed in lecture 1 concept of safety engineering, introduction and objective, safety engineering scope, evaluation of safety, historical background, safety concern that is a new area, safety cell and safety function. In lecture 2 we have discussed safety at workplace, general awareness of ergonomics, workplace operations requiring safety and safety benefits. In today's lecture 3 we will discuss about safety by design for under the introduction to industrial safety engineering. This will cover life cycle phases of safety design, benefits of safety by in design, opportunity to influence safety outcomes, and summary of all the three earlier lectures, that is you can say summary of introduction to industrial safety engineering, that consists of lecture 1 concept of safety engineering, lecture 2 safety at workplace, lecture 3 safety by design. That means a cumulative summary will present in section 3.4. Understanding to the discussion, you will be able to reply what are the benefits of incorporating safety at the design stage of an equipment or plant. Designer and design concept will discuss in order to manage work health and safety risk during the design stage. Designers should consider A. Physical design of a product, B. Work layout to reduce the possibility of hazards occurring in workplace, C. Applying risk management principles to the design process to eliminate hazards that may occur during operation, D. Designing work to minimize the risk to workers. Next, E. Creating healthy and safe work requires job and tasks be designed to accommodate the ability, diversity and vulnerability of workers, including those returning to work following injury or illness. It has been observed that within the work health and safety regulations, designers fail to consider to eliminate or minimize risk within the design process in relation to noise, that is covered under section 59 of Factory Act, hazardous manual task, confined space covered under section 64 of Factory Act, and plant under the two divisions, that is normally we call division 5.1.2 and division 5.2.2. Construction work under section 295. Example of poor design are this in this hall there is an emergency door, but it is at a significant height, and in case of emergency person cannot climb to the door and he cannot escape safely. In second right hand side picture, it is a packing material used for a particular brush, but there is a pin which is denoted by the red color arrow, that this pin cannot be removed easily. We have to use some techniques, some jugaad you can say, a jugaad to take out the pin. If it is a screw, then it can easily be taken out. But this pin is a riveted pin. Therefore, it will be very difficult to take it out, and this may cause sometime injury due to poor design. In this left hand side picture, you will see that the hair dryer body has melted. This body melted shows the example of poor design, because the designer have not taken in consideration the temperature of the body of the hair dryer. As such, it have melted. In the second design, very funny, that a wall is there shown by the red color arrow. In this shisha, if this rotating table, a person suppose sit and it is rotated and his head will be striking against the wall. This is a example of poor design. If we talk about safety by design, then this means that the integration of hazards by identification and risk assessment methods early in the design process to to eliminate or minimize the risk of injury or loss throughout the construction and life of the project being designed. Here part is very clear, that is throughout the construction, whenever there is a construction and the life of the project being designed. In a 5-step approach to engineering design, which results in ability to demonstrate that hazards to people, the environment, assets and reputation have been systematically and comprehensively identified and eliminated or controlled during the design phase of the facility or the system or the equipment. These 5 steps are: step 1, defining safety goals. Goals should reflect regulatory requirements, legislation of risk and sustainability strategies on safety and environment. In step 2, we should understand the hazards. If hazards are not known, they cannot be controlled. Project specific health and safety hazards and environmental impact should be understood well in advance. In step 3, we should implementing inherent safer design principles. Inherent safer design can be achieved by adopting a strategy based on following principles. A. Elimination. This means removal of dangerous material, process and activities. B. Minimizing. If elimination is not possible, then we will go to minimize the risk using smaller quantities of hazardous substances and minimizing the number of hazardous activities. If this A and B both are not possible, then we will substitute with replacement of hazardous or expensive material or activity with a lesser hazardous or expensive material. If we cannot control the hazard up to a certain degree or required degree by above A, B, C, then we will go for the next principle, that is moderate. In this case, we minimize the potential impact of release of substances or energy and the number of people exposed to it. And then next is simplify. This means the eliminating complexity to minimize the possibility of human error. In step 4, we will manage the residual risk and environmental impacts. Residual risk means whatever we have controlled, we have controlled. Behind the limit we cannot control. Therefore, we have to manage whatever risk is available so that there should not be any injury or loss of property and impact on the environment. If inherent control cannot be fully achieved as discussed by the above process or is inadequate, residual risk and environmental impacts will remain and need to be managed. This may require additional engineered or procedural controls. In step 5, we will consolidating and communicating. Once the safety by design process has been completed as required and the goals identified in the first step have been met, the process may be closed. The findings are consolidated and communicated to the extent and internal stakeholders. As a result of the safety by design process, the overall risk of operation of the designed equipment plant are minimized by eliminating hazards or applying the right hazard control to minimize the identified hazards. Furthermore, the design elements to control or eliminate the hazards are identified and designed early in design process when the implementation cost is at minimum. This is very significant that the design element to control or eliminate the hazards are identified and designed early in design process when the implementation cost is minimum. Why? Because at a later stage we will have to invest enough money for correction of the design defect. The importance of design is visual by these two figures, that in the first triangle affected by safety contraventions and right side triangle shows the ability to influence safety. In both the cases, you will see that how affected by safety contraventions the design and ability to influence the safety. We will go through the operators. You will see that in case of a faulty design, what will happen? The operators, the ability to influence safety in case of operator will be least. That operator can't do anything once anything is designed which is not safe, because he has to operate somehow. Therefore, ability to influence safety will be least. However, he will be the most affected person by the safety contravention. Whatever rules regulation has not been followed to design the safer design, the operators will be most affected. Second coming the manufacturers. If there is a unsafe design, then manufacturer will be most affected, but he will be least ability to influence the safety, because safety decisions he cannot influence, because he has to manufacture. Work order has been placed. Therefore, he will be affected. He has to manufacture somehow with the whatever design is there, and there will be more possibility that during manufacturing more accident may be there. Therefore, but at the same time he will not be able to change the design. He cannot ability to influence the safety. Whatever safety has been given by the designer, he will be working with that safety. Now the designer is the most important person, but however, if he is not affected too much by the safety contraventions, because he can design and he will give the design for manufacturing, but at the same time designer have the ability to influence the safety at the maximum extent, because he during the process of design can find out which is the things as per statutory requirement of safety, or otherwise safety principles if ignored, then he can very well take care of such ignorance or the other things which has not been taken care during the design process. Then the customers. The customer is least affected by safety contraventions. Why? Because he has the choice. He has the choice to have to purchase a more safer product. But ability to influence safety will be most for the customers, because once he reject a product to purchase only due to the reason why, because it is due to unsafe product. If it is unsafe product or a product is not having the safety features, he will not purchase. The most of the product will not be purchased. That means the sale of such product will not happen, and there will be accumulation of such product. Therefore, the industry have to take care of such things, and he will take care of the safety features. He will incorporate the safety features which a customer who is least affected by safety contravention purchase such items which is already available in the market, which are more safer. Therefore, ability to influence safety is much more with the hand of the customer. He is not affected by safety contraventions. Example of safety by design we can put like this. Example of minimizing working adjacent to high speed traffic. A steel footbridge was erected over a busy roadway. Single span was practicable and was chosen so as to reduce dangers to road vehicles. A lightweight design was utilized, enabling the bridge to be lifted into place during the single road closure and held on a weekend night. Overnight, due to this good design, this could be possible that without any exposure to the hazards, this lightweight design was utilized and enabled the bridge to be lifted into the place during a single road closure held on a weekend day. Or else, suppose this is not a lightweight design, and if it is not a single span, then the road closure might have been for several weeks, and when this several weeks people will be adopting shortcuts, and then it may lead to injury. There was minimal need for temporary works. Temporary works is always required for any such erections, but at the same time they are not as safe as the permanent work. Therefore, we have minimized by this design, the risk has been minimized. The connections and lifting points were designed to allow speedy pre-assembly, because ready to use assembly are available if we are doing the welding, and other structures are designed for erections of the footbridge, then it will be requiring more time. But if it is already pre-assembly is there, then it will be speedy, therefore it will minimize the total requirement of the hours of working for erection of the bridge. We will see the next example of safety by design. It is designing out the need to perform work at height. A designer had specified timber cladding on a building facade, including the gables. All the cladding would be accessible for periodic maintenance by mobile elevating work platform, except for one gable adjacent to a narrow passageway, because in narrow passageway that mobile platform cannot go. The cladding on the gables was replaced by a low maintenance anodized aluminum cladding. Therefore, in this cladding, anodized aluminum cladding will not require maintenance as frequently as normal cladding. Therefore, this task has been made easy and safer. Another example we are giving, a designer had specified that air conditioning units be mounted at 2.5 meter high on an external wall. As shown on this arrow, you will see this would have required periodic access for maintenance, and ladders would likely be used if it is at the top, at the height of the 2.5 meter. What designers did, working on ladders is a high risk activity, and the designer changed the mounting height to 0.6 meter to avoid the need for work at height. You can very well see that this mounting has been brought down at the working height of 0.6 meter. Therefore, we have avoided, the designer has avoided the maintenance at a height more than 2.5 meter. Another example, we are taking that example of painting the tall building. A designer considered the use of a water-based paint for the exterior, a metal spire on a tall building to reduce exposure to solvent. A metal frame would require more frequent repainting with a water-based paint. Therefore, designer concluded that it was better to specify the solvent-based paint because the high risk of frequent working at height. So, this is also an example of safety by design. Now, we will see what are the life cycle phases of safe design. We can split this in 5 phases. In the phase 1, the design will be done by the designer. In phase 2, the construction work will go on and the plant will be erected the equipment will be installed. In stage 3, the operation will be carrying out. Once for one night after 2 years, then maintenance will start in phase 4. Therefore, after good quality of maintenance, operation will continue. If poor quality of maintenance there, then it will lead to the disposal, stage 5. That is the end of the life cycle of the safe design. What are the benefits of safety by design? If we see in different life cycle phase, we will see if it is a design stage, then risk if identified, it is a safety benefit. Risk reduced or controlled, then again it is a safety benefits. How project is benefited by this safety benefit? At reduced redesign or retrofitting, as well as reduced life cycle OHS cost. Then at construction phase of the life cycle, what happens? How safety is benefited? Safety benefited by communication of residual risk to contractor and reduced likelihood of accident. If contractor is informed regarding the residual risks, what are the risks involved are available, then reduced likelihood of accident will be there. And the project will also benefited that the informed contractor reduces risk of contingency. Decreased time will be decreased in implementing the project, and no overrunning cost will be occurring. And the third stage of operation, if a designer that if it is a safe design, then safety will be benefited, that occupant health and safety will be sound, as well as public health safety will also be maintained. And how the project is benefited? By this way, it will be that a reduced cost will be there, that is absence of claims, that absence will be less and claims will be less. Absence and claims both will be less, and company image will be reduced civil claims and the litigations, therefore naturally company image, the reputation will be high. And life cycle phase 4, that is maintenance and repair. In this phase, safe access for maintenance and repair strategy. And the last phase of life cycle, the safety will be benefited, that is in demolition and refurbishment, the communication of residual risk is there, and reduced likelihood of unplanned events. And project will be benefited that informed contractor reduces risk contingency and decreased time and no overrunning cost. Opportunity to influence safety outcomes is also shown in this graph. It is very much clear that it will be very ability to influence safety versus project schedule. Ability to influence safety will be low, ability to influence safety will be very high in the beginning of the project. However, as soon as we move to conceptual drawing, detailed engineering, procurement and the construction, then there will be a midpoint. At the midpoint, there will be ability to influence safety and the project schedule will be same. At the end, if suppose startup, if some unsafe things are there during startup of plant, suppose some unsafe design feature is noted during the startup of the plant, then cost will be very high for rectification of such unsafe design. Now we will summarize safety by design that we have covered in this session. Life cycle phases of safe design, benefits of safety in design, opportunity to influence safety outcomes. And let us also summarize the complete chapter, Introduction to Industrial Safety Engineering, covered in lecture 1, Concept of Safety Engineering, lecture 2, Safety at Workplace, and lecture 3, Safety by Design, that is this lecture. Safety and health of a workman in workplace is important for industrial practices to benefit all. Today, safety concerns are widely regarded essential in industry, and government make regulations to see that employers implement safety practices. However, this concern started to be felt first in 1912 in USA. Before it could mature, the onset of Second War diminished the importance of safety. The industrial nations of that time sacrificed safety for victory in war, but soon the professionals were convinced that safety could not be overlooked. It not only established itself as an essential practice, but also developed into an academic subject in its own right, requiring specialized knowledge and research. Thus, trained and educated safety engineers became available. Now the industries follow safety directives and policies made at corporate level. At company or factory level, the implementation is guided, reported and audited by trained personnel. Such policies also keep government regulations in mind, and the compliance is necessary. Regular safety drills and training of workmen, availability and upkeep of protection gears along with written instructions have become common safety management functions. Each industry must identify its safety functions and operations that will attract safety considerations. Sound safety policy keep all three employers and the customer satisfied. Thank you for listening to the lecture.